Okay, hi Josie, hi everyone. Do you hear me okay?
Yes, perfect.
Okay, very good. So I'll try to share the slides.
That sounds good. Fantastic. We see your screen.
Yeah.
Thank you. Thank you, Matej.
Wonderful. So I have 10 minutes, okay? So I'll try to stick to the time. So yeah, good afternoon, everybody. My name is Matej Hoffmann, and I'm from the Czech Technical University in Prague. And so I have a slightly provocative title, which is this embodied AI. So you probably have come across it. So our conference is called Embodied Intelligence, but there is this embodied artificial intelligence around. And this has very, let's say, bold claims, among others, like generalizing across bodies. So they want to develop these huge models that will basically work for different robots. And so I want to ask, with my background in embodied cognition, whether this may actually work. So I come from this crowd from the lab of Rolf Pfeiffer. So many of you, many of my colleagues are here. So just that you understand sort of the background. And this is my current lab in Prague. There is a postdoc PhD students, and there are robots. Yeah, I put only one here, which is my favorite robot. This is the iCap. All right. So yeah, I don't have to like preach to the choir. This is, embodiment. So the behavior is not in the brain, it is in the interaction. This schematics tries to convey all the different loops between the mechanical system, the body, the environment, and the brain and the sensory system. And this morphological computation is a very related concept or buzzword that also, has these facets how the body can help us to behave. So to generate control, to control robots in the real world with a little computation, say. It can facilitate perception, like, for example, this famous insect eye morphology. And taken to the extreme, it may even compute, like this reservoir computing is an example of that. Okay, so much for the introduction. Now, what is this embodied AI, and how does it, let's say, what is common and what is different? So this embodied AI is now all over the place. So for example, it was the theme of the IROS conference. There is this embodied AI workshop at CVPR. So these are the traditional computer vision and machine learning venues that now embrace basically what they call embodied AI. And I want to basically bring it up here to this community. What does that mean, and what should be the best action, like from our perspective? So the tasks that they typically tackle is tasks like rearrangement, visual navigation, vision and language, audio-visual navigation, scene to real transfer. And the environments, they typically look like that. So they have these kind of typically virtual, or actually exclusively virtual environments. Very often with the mobile robot, it's somehow related to navigation. So there is a rendered scene, and the robot needs to go to another room or pick up something. Yeah, so you see the examples yourself. So these are some kind of, let's say, household kind of like environments typically. And now, is this basically like connecting a deep neural network to a robot simulator? Is that all there is to it? So here are some examples of their challenges. And this is our, let's say, the embodiment diagram. And so my interpretation is that the tasks are really weakly embodied, so highly abstracted. So it's like a mobile robot going from one place to another, as one example. And the interactive actions are not central. So for example, here, there is a list of these challenges or benchmarks that they have. And none of these, for example, contain interactive actions, meaning it's like an offline data set that has been collected, like somebody driving around with a vehicle in that virtual environment, collecting sensory data. But now if you want to learn from these, like what was the best course of action in a given context, you will have to rely on that already collected data. Some environments do have those interactive actions, to be fair, but it seems that it's not like a central tenet of this approach to have these interactive actions. So while this whole diagram kind of which is which illustrates embodiment. There is this information self-structuring. So the information that gets to the brain is shaped by all these loops, so all the interaction of the physical system with the world, but also the actions that the robot takes will shape all the rest. So in our view, or in my view, for efficient learning, it's absolutely necessary that you can take the actions yourself, right? And so learning from offline data sets, I think, is severely limited. So they have these data sets. This is a screenshot from a talk by Sergey Levin, and he's one of the figures in this community. And with these big shared data sets, so something like ImageNet for robots. So this illustrates kind of where they come from, because they come from computer vision, and ImageNet has led to a lot of progress there. And so they're trying to bring this to robotics. So what should it contain? Generalize over tasks, over scenes, or maybe even over robots. So here it said, that was in 2 years ago. We leave this for later. Probably some of you have noticed that there is this DeepMind initiative on this Gato, this generalist agent. And even more recently, there is this OpenX embodiment. So that's like a collection of different labs and a collection of different robots, where they are creating this multi-robot dataset. And they're using these models based on this RT1 and RT2. So it's transformer models that take vision and language as inputs. And they output basically the, say, XYZ coordinates of where the end effector of that manipulator needs to go in the world, plus whether it should open or close the gripper. So it's quite high level, it's abstracted, and it doesn't yet, at least the paper just mentions that they haven't tried generalization across the robots, but that's surely where they want to go. At the moment, it's generalizing more over tasks. And of course, this is really driven by the progress in transformers, where vision and language, there's a lot of data and there's a lot of things that they can do with these kind of inputs. And now they want to basically scale it up to interaction in the real world. However, as we all know, biological intelligence is not following the same path, or has not followed, evolution has not followed that path, because different bodies yielded different brains and different controllers. So you can, for example, compare the human with the octopus, or you can look at these brains here. The red parts would be the somatosensory, so basically touch and proprioception. A stands for auditory, and V for visual cortex. And so these, for example, these three animals have a similar size of cortex. And yet, because of their habitat, because of their bodies, because of their ecological niche, they evolved very different brains, right? This is a similar picture, and yeah, this is yet another story from the evolutionary viewpoint. So now this is the question. So maybe the transformers or the foundation models will give rise to a new kind of intelligent cognition, which is cross-embodiment. Maybe we can just afford to have these gigantic multi-body brains. But for me, as a sort of an embodiment veteran, this seems odd, right? Or it seems that this is principally not right. But it doesn't mean that it will not be possible. That's why I'm bringing this up to to discuss it. With you. So on one hand, we have these kind of environments, and on the other hand, we have our embodiment and morphological computation. So basically, what I think where they are currently right now is that they have their deep learning architectures, and they give them the body by closing the loop with reservation, because I don't think it's very strongly close the loop, for example, because there's this focus on these offline data sets. They are slowly going multimodal. It's still heavily, let's say, vision-based, and now also language-based, because these are the most successful types of models. The embodiment is weak, so they don't go beyond move to XYZ and close the gripper, right? They don't do dexterous manipulation, for example. They cannot tackle tasks that I think they inherit a lot of what you can read let's say, on the internet, what ChatGPT, for example, can reproduce. So that it can tell you, pick a cup and put it behind the other cup. But how you can actually do it, that grasping the cup might actually be a challenge. That's not something that they focus on. So what is not exploited is things like that morphology simplifies control, that it can facilitate perception, all this information self-structuring. So basically all these concepts that are, I think, essential for the way we understand embodiment and embodied cognition.